All right. So good afternoon, everybody. Today, yeah, let's just me share my screen and then we can go ahead. All right. So today I will be talking about basic understanding of functional programming. Functional programming, it's been increased a lot, and I think everybody in the development field heard about that term before, but maybe you don't know exactly what it is. And this talk will be to answer some of your questions and perhaps answer, at the end, we also have a section to answer questions that was not covered in this presentation. So a little bit about me. I am a senior engineer for about 8 years. I mainly work with Java, and my main focus is in the backend engineering. I also done cloud computing for big data in Canada 2 years ago. Besides Java, I have worked with Python for 2 years, about 2 years, with Django as well, and Scala, which is a functional programming by default. The main focus of Scala, it's functional programming. Also, I have some experience with machine learning algorithms such as k-means, linear regression, naive Bayes, and that running on top of Spark. When we have a huge amount of data, Sparks give us better performance for those algorithms. And I think that's what I have that's me. Do you think we can start the presentation already, Shayla, or you're good in time to start?
No, we're good. Yeah, let's start. And this is a good part for people to see us. I think you're sharing your notes as well with us. I'm not sure if that was intentional or not, but we can see them.
Oh, well, I think that's the next slide. If that's
Okay.
there, I don't think it's a bad
That's
thing. Yeah, that's just the next slide.
okay, perfect. Then
Let
thank you
me
and
make that, yeah, that's better, no?
perfect.
All
Thank you.
right.
This is what you get with live TV.
All right, so why functional programming, or what it is? When you see this picture, you can imagine about our math classes in high school or so, or in college. But yes, I promise I will not explain those functions here. This picture is just made for let you know that functional programming gets from the math its precision. So functional programming brings the precision of math into programming. This phrase it's pretty strong in this context, and I will explain you why that happens. And as you all know, programming has a lot of math, but we mostly, when we are using object oriented or any other program paradigm, we don't use only math functions specifically. And yes, I will tell you why. So as most of you has a background in procedural or object-oriented programming, I will make some differences here between those two, which are classified as imperative programming paradigms compared to declarative approach, where functional programming is classified. So as we have here in the left side, imperative languages defines a program as a sequence of statements that change the program's state until it reaches the final state, compared to declarative, which is express the logic of a computation without describing its control flow in terms of a sequence of statements. That said, I will explain the next slide what's the main difference between those and how you make a code in imperative language and declarative. Just a small example so you can understand those differences between those concepts. And imperative, we also have many side effects. which will be also talk in the next slides, where in the declarative approach brings the precision of math into programming, such as f of x equals to x times 2. In this example here, whenever we call that function, the results will be the same. So we give a value for x, and then if I call that function today, the value will be the same. 1 hour after, the output will be the same if the input is the same, and so on. And that's the thing we get from math, the precision of those functions. And how you can do that? One approach is immutable variables instead of mutable variables. That's one thing that we should avoid using if we want to migrate from the imperative approach to the declarative approach. And we also will talk about impure functions compared to pure functions. So pure functions needs to follow some rules that if that function doesn't follow those rules, it's considered an impure function. And most of all procedural and object-oriented functions we write nowadays, they are impure by nature because they don't follow some of the rules we will see also in the next slides. This is just a small difference between those two approaches. And then let's go ahead here. For example, if we wanna compare the declarative and the imperative approach, in the left side we have an array. Basically, let's talk about the declarative approach first. X is the sum of all numbers in the array divided by the length of the array. So with that, we know all the context of what we are doing. We are getting a AVG, average of the numbers inside an array. So if you read the right side, which is the declarative approach, we can understand that better compared to the imperative approach. Set x equals to 0, add the first number in the array to x, repeat steps 2 for the rest of the numbers in the array, divide x by the length of the array. So if you are doing an average using the imperative approach, we have some steps, but in the declarative one, we know the context itself in one phrase, not in steps by steps. Okay, so going on that, when you use the functional programming concepts, instead of having a lot of code that you don't exactly know what is happening in the other side, what variables are being changed in a runtime environment, especially when you have many developers working, you have a shared state, it's hard to predict what will happen because most of the methods and functions, they are time dependent, which means if we call one function before the other or 1 second later, the result of that function can be different. And that it's the main cause of issues, bugs, and those bugs are mostly hard to track and even hard to reproduce because they need many steps to reproduce a sort of bug. But when using functional programming, time doesn't matter. One function that you have written 10 years ago, and if you run that today, if the inputs are the same, the outputs should be the same, no matter what. And we can achieve that using not only immutable objects, but there are other techniques that we can use to make functions pure, and then we can achieve that main goal, which is every developer is able to see what is happening, what are the inputs from a function, what are the outputs. There is no changes in those objects inside that function. The objects that are processed inside each function, they can't be changed by other method or other call. So what is functional programming? Often abbreviated FP, is the process of building software by composing pure functions, avoiding shared state, mutable data, and side effects. So that concept is simple. So, but to apply that practically, it's not that simple. So what we can do in the next slide, we'll see some examples how to apply those concepts. Composing pure functions, avoiding shared states, mutable data, and side effects. Even if you have a team that doesn't have much functional programming knowledge, or the company is not prepared to migrate totally to functional programming, if you apply some of those concepts in even oriented object oriented, you can still earn a lot of readability and avoid bugs in your code as well. So let's see those concepts. Here we have some. It's hard to talk about something without showing you some code snap and to show you practical examples of that. I would like to give those examples so you can understand better what are the benefits of that. So for example, in this snippet code here, we have a function that takes, actually this don't takes any arguments, it just validates if this logged user is different of null, and then try to access the get name property of that object. Generally, if you create unit tests for those sort of methods, they will pass without any problems. We can't see any bugs in this sort of approach. But let's say you have a logged user that is a session variable, and then at the same time the user clicked in to call a specific function, the user also clicked in a logout event. Then that variable is set to null or something else. Something will happen with this logged user, but at the same time, concurrently, there is another process trying to get the log user. And supposing this first line was already executed, and after that the object is null, what happened? This will throw an this will automatically throw an exception, because this mainly will be a null pointer exception if that object is set to null right after the validation here, because this is mutable. So any method in the system can modify that value. And even though you have a business rule inside that guarantee that object is not null at that time, in a fraction of a second, another thread could come up, change that value, and then you get an error. So those sort of bugs are pretty hard to track and reproduce because they are time dependent, and sometimes there are many sequence of steps that needs to be done to reproduce the same sort of bug. And how to avoid that? Immutability, it's one of the concepts. Shared state, if you have any shared object, we are talking here that you can still have shared objects, in my opinion. This is my opinion. You can still have, but not variables. You can have that as constants. Let's say you need to use one property in many times, in many places in the system, you can create constants. So once you give a value to that constant, you cannot change that anymore. And then that can be used in a shared state, just in that case. Other than that, you should avoid any call to this, and objects that can be mutable, they can cause issues. And yes, I already talked about immutability, but here I have just another slide to reinforce that concept. objects, an immutable object is an object that can't be modified after it's created. So we also see many of those concepts when we are talking about immutability. We are just giving other names to values. For example, I want to save the value 10 in a space of memory, so I will call that value of 10 x. I will give a name, x. X will be always 10 in your environment, in your software, in your runtime environment. So that value cannot be changed. If you need another value to name, let's say you need 11, 12, you give another variable name to that. So that's how you think about immutability. If you need something new, create a new object, another space in memory for that object, but don't change the ones you have created. All right, and side effects. A side effect is any application state change that it's observable outside the called function other than its return value. So side effects, we can add here, for example, database access is one side effect. If you have that in your function, in your program logic, in your business rules, if you work with MVC model, your service layer or your business rules layer, they should not have calls to any of side effects. You should avoid many of those in your code because they cannot be validated through unit tests. For example, if you need to unit test those, they can give you unexpected values. And for functional programming, we need to avoid the unexpected as much as we can. The unexpected need to be avoided. So examples of that, if we are writing a console, let's say you have a method that do some computation, and at the end you are writing that result to a console or a log file, or writing in a database, calling an external system. That's an external step. That's an external effect. It's a side effect. So you should separate your business rules from your side effects, from your external calls and anything else, because you will be able to validate better your business rules. You make sure your business rules are protected from failures, from external failures, and then you could make those pure functions. So to make those pure functions, those side effects cannot be inside those specific functions. So the next slide is exactly this. Pure function is a function that, given the same inputs, always return the same output. No matter what, no matter when, it's not time dependent. The inputs need to be the same. Has no side effects, is stable, consistent, and predictable. Have no interaction with the outside world apart from calling other pure functions. So talking about those concepts, you may think, oh, but it's impossible to write a system only using pure functions. Yeah, that's correct, because we need to talk with the external world. But the main concept of this paradigm is you can separate your business rules from your external changes, external calls, and everything else. Other than that, business logic go under pure functions. Just have a question here. You may answer in the chat if you think this is an example of a pure function or not. And if you want to say why or not, it's up to you. We have a simple function written in Java. I think most of you may know it's a simple one. This is a ternary operator here, and we are using some values. So yes, if you want to take a guess, Yes, just write down the console, in the chat, sorry. And then, if you have not answered yet, this is the result of that as a pure function. Why this is not a pure function? It's because we have a variable here, which you call limit, and this variable here gets the value of 100, but it's outside our method, calculate bonus. So if the variable is outside our method, means that value can be changed, which means this is not an immutable object, so this is an impure function, mainly because I have access to outside variables that are not final, they are not constant. So if I could do that if that limit variable was a constant, but not as a variable as we have here. So this could cause issues because, for example, for the first time, I could get one value as return of the calculate bonus. But if some method changed the limit variable to 200, 500 or so, that output could be different. So that breaks our rule of for every input, same output. Oh, same inputs, same outputs, sorry. So to not break our rule, what we could do, we can just change the limit variable, put a constant value inside our method, and then this will be a pure function. We have the inputs from the method, and the output will be always the same, no matter what, if we have the same inputs, of course. All right, now, as we know a little bit more about functional programming, let's talk about the syntax of functional programming. And we could not do that without talking about Lambda functions. Lambda was introduced in Java version 8, and most of the the most popular programming language nowadays, they also have some Lambda support. So even if you are not a Java developer, you can see some similar syntax where we have Lambda functions with 0 parameters as we have here. It's just an empty parenthesis. There's nothing inside the parenthesis, and then some computation after the slash sign up here. At the right side will be the computation. When you have one parameter, we could either use between parentheses or not. It's optional. The parentheses is optional when we have just a single parameter, and the computation at the right side as well, the arrow. And for multiple parameters, in that case, we need to use always parentheses. So if we have variables 1 and 2, we can specify those, and we can use those in the right side of the arrow as well. We can do some operations and anything we need. We have some examples of Lambda functions in the next slides, but this is just for you to understand what are the syntax of that command. And another important concept are the functional interfaces we have in Java, in other languages as well. Those interfaces we can create mainly to reuse code, or codes that it's too big to put in only Lambda functions, or if I think that the best thing is reusability. If you write a piece of code that you need to reuse, the best way is using functional interfaces for that. And we have 4 different types. The first one, it's a function which takes inputs and outputs. Always will take at least one input, but can be many, and will return a value. Can be an object, can be an integer, can be anything you can define. your type of return. Predicate, it's another type which gives inputs and gives a Boolean as result. So a predicate will always give a true or false value. You need to do some sort of comparison between that, and then true or false will be returned from a predicate. And we also have a supplier, which it's a void method mainly. It just get inputs, but no outputs. And we have the consumer, which is the opposite. Consumer will take some, sorry, the consumer it's a void, doesn't return nothing, and the supplier here, it's just the opposite of what I said. Sorry about that. But yes, when you have function that needs inputs and outputs, you use the function interface. When you need to use a Boolean value, it's a predicate, and a supplier and a consumer when you don't have either parameters or outputs. We'll see examples of those as well. So here we have the streams API, which is very popular in Java, in other languages as well. The streams API, they take some inputs, which can be an array and collection of elements. Streams, it's mainly for doing iteration. You have a collection of objects, you need to iterate over those, and there are a lot of operations you can do in those elements. So instead of using for loops, while loops, you can use streams. Basically, everything that you can do inside a for loop, a while loop, you can do using streams instead. And what are the benefits of stream? It's functional, it works in the functional way. So if you try to use a variable that it's not final, it's assigned more than once inside a Lambda function, inside a streams operation, you get an error. So the compiler will not let you to do that. So in that case, you can avoid mistakes just using those syntax of the streams API and Lambda functions as well. So we have a collection of elements as input. We can perform operations such as filtering, sorting, conversions, mapping. And then once we finish, we need to have a final operation to convert the stream of elements we have into a list, for example, or a single result. Sometimes if we want to, for example, filter the even numbers and then get the sum of the even numbers in an array of integers, we will use a filter first and then a final operation that can be reduced for this sort of example. We will see an example of that as well. So just an introduction about the streams API, and I will be covering the most common operations in the stream API as well. So let's go to see some code again. We have here a list of staff, which has a name, age, and a number that can be a salary or something else. We are iterating over this staff, and we are adding at the result variable the name of each member, staff member here. And then we are printing out the staff members in this line. So with Java 8 using streams, how we can do that in the same way? We can use the staff, which is our input. It's a list of staff, dot stream. This keyword will create a stream of elements for us automatically. Then we can operate all of those. We can use all of those operations, which are filter, map, reduce, and so on. So here we are mapping because we are keeping the same amount of elements. The same with a number of elements will be our output as well. So in this case, we use map. We are just interested in staff.name. So X here represents staff, as we have here, and then get name. And then our final operation here is this collect operator. The collect operator receives some sort of inputs that in this case can be a list, could be a map. You could create a totally different sort of object at the end. You can create your own objects, but the collect method has some default that you can use. And one of the most used will be the collectors.toList, which will give us a list of string, because the name here is string. Names are string, so the result of the get name will be a list of string. So doing that, we have the same result as using the for loop without using any for loop. And if you see, you can write that in just a single line of code as well. You need some practice to get that syntax, and I will have two more examples if I'm not wrong. I have the filter as well. Filter is when you need, for example, do some predicate operation that will return true or false for some elements. So here we have a comparison. If mkyoung is equals to line inside a for loop, and then adding those results to a result variable. And then we have the other way to do that using streams, which is the same collection I am iterating over, lines.stream.filter, in this case, not map, but filter. Then we do the predicate condition here using Lambda syntax as well, but could be a predicate interface. And then we see that it's different from what we are looking for, and then the collect method again. So for map filter, we need to use the collect, which is the final operation. For reduce, we don't need to use that collect, I will show you, but for those methods, we need always to use the collect, and then to get something that we can work with as a final result, unless you want to pass that result to another function, then you can keep that as a string. But if this is your final operation, you don't need to do anything else with that value. You need to call the collect operation. So this is another example of reduce. What reduce does is it iterates over an array of numbers, and here we are creating an accumulator of those numbers. We are getting the sum of 1 plus 2 plus 6 plus 10 plus 11. So this is before Java 8, before string. This is the way you should achieve the same result, iterating over numbers, creating a sum variable that is mutable. This sum variable, it's mutable, which we always avoid in functional programming, because we are creating a sum stream here, which will be given just a single value, not a mutating value. We have a mutating here, which is our accumulator. The A here in this syntax it's our accumulator. That's the only thing that will be changing over the time during that processing. The B, let's say the first call of this will call 0 plus, which is our initial value, plus 1. Then we have 1 as accumulator, 1 plus 2, and going on that, in that direction, until the end of this array, until all elements get iterated and we get a result as 30 here. Same as here. same context. So yes, another good thing about stream is the parallelism. We can use multiple threads to do the job pretty easily. We don't need to worry about any unexpected thing during parallelism. If you need to make those algorithms by hand, you may notice that some bad things can happen. Maybe you don't keep the order you would like to. Maybe some of other issues came up. But with streams, you can just add, for example, in this example here, you can use parallel streams to use more than one thread working in the same job. In this example, we have an iteration from 1 to 1 million, and we are printing the prime numbers from 1 to 1 million. And as we can see here, without parallelism, this will take about 1 minute and 10 seconds. Of course, depends on the computer you are running. And with parallelism, you can take only 23 seconds. Basically, 1/3 of the time if you use threads to do the same, basically the same output. So yeah, it's pretty useful. And the only thing you as developer need to do is the dot parallel here, or also use the parallel stream instead. All right, we are almost finishing. Just there are a few more concepts that I would like to cover. Function composition, which is an important concept. In mathematics, function composition is an operation that takes two functions, f and g, and produces a function h such that h of x equals to g of x of g of f of x. So what that means exactly, we can see that we can combine functions together. We don't need to have a huge function that do a lot of processing. We can just combine those in a way that will be more readable, can be usable, reusable, is small and on topic what you are doing. But it's pretty hard to achieve that with only a single function. So what you do, you combine many functions that the main function will be a huge function, but the internal functions can be easily readable and understandable. So this is an example of function composition using streams. We have an array of numbers. We are doing so the problem that we need to solve with this algorithm is, given an array of integers, multiply each element by 3 and return the sum of even numbers. So here we cannot do that with a single operation. We need to do more than one operation. So first, we will need to multiply each element in our array by 3 using a map function, map number times 3. And then we have a filter. Now we want to just filter the even numbers. Mod 2 equals to 0. And then we are using a reduce function at the end to accumulate those values. So now I am returning the sum of that element. This return an integer value. The reduce don't need to use the collect operator, which is the final operation, because reduce, it's by itself a final operation, which returns a single value. If you are iterating over strings, can return a string, but because we are iterating over integers, it returns an integer as well. And one more example with function, using functional interfaces to do that. Because the example that we saw here, it's a pretty simple one, but in real life, you may get more complex problems to solve, and problems that cannot be solved in a single line, problems that maybe can be reused, that part of the code can be reused by other methods. So for that, we have the interfaces that you can specify your functions. For example, here I have a function that takes an integer as input and gives an integer as output as well. What this function does, it just multiply the input by 2 and return that number. The other function I have here, just add 5. But those can be, if you use brackets here, you can, not brackets, curly braces, you can have a bigger number of lines. It doesn't need to be in a single line. It can be 5, 10 lines. Depends on what problem you are trying to solve. And you just need a return keyword when you have more than one line. But here, because we just have one line after the arrow, we don't need the return keyword for that. So if we wish to combine those two functions, we have the option to use the compose option, times2.compose add 5. So this can be weird for you, but here we are assigning functions to variables. So this is what the functional interface does. We can assign functions to variables to use those functions whenever we need those. And we can compose those functions. We can create a function that is made by 2 other functions or 3 other functions. So we are doing the compose here, add 5. I just would like to know that there is can be a tricky thing here between the compose and the and then, which does the same thing, but processes the first time, the first piece, the first function first, and then the second. But in this first example here, the add 5 will be run first, and then the times2 will be run after. And that can give us different results depending on what you are doing. But in your case here, it gives different results. So be aware on that. Of course, if you are working with unit tests, JUnit, you can easily catch that in a unit test. But yeah, if you don't know why you are getting a different result, it's because here, add 5, it's running first, times2 is running second, and here's the opposite, times2 and then add 5. And then how we call those those functional interfaces, we use the apply keyword instead. We have a result, we want a result of that function, times2 and 5 combined, dot apply. If we have just a single parameter as we specified here, a single parameter, then we pass that parameter here and we get the result from that, which will be also an integer as we defined here. Can be string, can be an object, can be anything you wish. You can define your function interfaces as well. For one parameter, I know Java provides. For 2 parameters, also Java provides. But if you need more parameters or no parameters, you need to define your own interface for doing that. All right. And I think that's it. I think that's all I would like to let you know. And of course, I hope there are some questions. And before questions, if you are interested in this topic, if this is something that you would like to keep learning, this is just an introduction. And there are some courses here that I recommend you to take, depending on the language you are familiar with. If it's Java, Python, JavaScript, PHP, here I have some links for LinkedIn Learning Platform, which is basically 2 hours, 3 hours course max that goes over all of those concepts in more details, because here we don't have time to expand in each of them. But of course, if you are interested to learn more, this is my suggestion for you, and they are good resources for you as well. Other than that, I would like to thank you, Ubiminds and Datatrak, for giving me this opportunity. It's always a pleasure to be with you guys, and thank you so much. If you have questions, let's go ahead.
People are very quiet.
Yes, looks
Yes,
like.
but Hylston, thank you so much for opening up and giving us this talk. It's always good to have, you know, people's idea kind of juggling around a little bit. Um, I actually have a question for the people who are watching here. Are you guys starting right now at functional programming? Have you already applied this? What? Why are you here? Use up Houston's time. Let's see.
I use it to do some Elixir stuff. That's pretty much functional programming, but it's a little bit different. We have some other concepts like pattern matching and stuff, but that's why I came here and to see some old folks here.
Call us familiar. Don't call us old.
Yeah, that should work too.
Yeah. I saw Mayane was really active in the chat. I don't know if you have anything to add here.
I just wanted to mention that I have used functional programming in development and such, and I was more interested to see, because even if you're used to something and you use it constantly, there's always something that something new that you could end up learning. So it's always interesting to see and revisit basics.
Yeah, I don't know if anyone wants to share some traumas. Maybe we can have a free consultancy session.
I can share a trauma maybe, because I started my final project in college. The first one I tried to do in functional programming. I used Elm, if I remember correctly. It's like I think it's closer to web dev functional programming, as far as I remember. It was a game, so it was kind of challenging to balance like all the side effects that we would need to have in a pure functional programming. It was very challenging, and then I changed course there. But I've had more a pleasing experience with functional programming when I worked with Scala in the previous company that I worked in, Juro Brazil. We had experience with Scalas, and then it was quite fun to work there. But my final project game with functional programming, yeah, I didn't have a good experience there.
I see. I think the main difficulty I see developers that already know oriented object paradigms or procedural, they need to learn almost a kind of new language, which is Lambda. Lambda, it's a bit different from what we have get used to. But even if you don't want to migrate to Lambda, some concepts that we talked here are pretty important for you, even if you are working in any other paradigm, programming paradigm. Of course, if you can use all of them, will be better. But if you start like creating functions that all the inputs and outputs, everyone that sees that function can knows, oh, this I have input A and B and output C, that's pretty helpful. But when you have a lot of these dot calls inside the function, that makes pretty hard to know what are the inputs you are using there. And if you are writing unit tests, it's pretty hard to mock all of those dependencies and so on. So yeah, that's my tip.
Yeah, and I see we have some new faces today as well. I'm seeing here Eliseu, Malu. You guys, if you want to give a quick hello and as well.
Yeah. Hi, my name is Eliseu. I'm from Brazil. And first of all, Hylston, congratulations for your talk. It was amazing. And I learned that functional programming is good to apply for the core application. Sometimes we can apply functional programming for many parts of our code, but it's good when you apply for the core application because you can it's safe because you can predict your inputs and your outputs, and you can make your code better. So thanks for your talking. I learned a lot about that, and I probably will apply this in my PHP codes. Java is not my place, but I certainly will apply for PHP core applications. Thank you.
Thank you,
Yeah,
Eliseo.
me, it's Malu speaking. I'm new because I was following Natann's presentation because we used to work in Canada, here in Toronto, when Natann was here. So yeah, it was first to support him, to make sure that was a great presentation from his hand. So also to learn, for example, to see how we can use streams. Me, it was interesting to see that because even though I've been working on Scala quite a while, but I'm not kind of comfortable with streams. So it was nice to see those examples. So, and then to use Parallel as well, so that that can improve the performance. So thank you, Natann, for that.
Nice to
Wow.
talk to you again, Malu. I miss you.
You as well.
Oh, I'm really happy to have everyone here. We have these kind of meetups every week. So we always bring new topics, and also if you have any suggestions of things that you'd like us to approach in the future, they're always more than welcome to contribute as well. Right. So I think we're done for time. Does anyone have any last comments? Anything else to add?
Great
Okay.
presentation.
I just want to congratulate Hylston. It's not easy to come with such a thing, but congratulations.
Thank you so much.
Definitely.
And I hope I give you a good understanding of the topic, at least to learn more. Keep learning. We always need to keep learning. This is the rule in our world.
Well, I just want to say thank you for your presentation. I'm not from the tech area, so I'm just starting here with Ubiminds. I'm learning psychology. I work with people, not so much with numbers. So I'm trying to dive into technology and learn a little bit more about this area. So it was really good to learn a little bit more, and hopefully in the future sometime I can like really understand everything. But it was really nice to learn a little bit today, and thank you for your presentation.
And Thais, maybe next time you can join us as well. We need some soft skills as well.
Yes, with soft skills I can help a little bit more. Thank you.
Okay, thank you so much. And yes, let's see next time then. Perhaps I will bring something new for our next group talking.
Perfect. Thank you, everybody. See you next week.
Thank you.
Bye-bye.
Everyone.
Take care.
Thank you.